Okay, so during the break, your classmate remind me that actually this equation is right. Okay, so if you can, if you refer to the equations for calculating the recurring costs with the discount rate and also the escalation rate, then the component should include 1 minus this ratio and then to the power t number of years. So I skipped some of the steps here in the calculations, but actually they are right. Okay, so you can study the equations and then you will find out how to do the calculations. Okay, so now let's take a look at the tutorial. Okay, so in the tutorial we have how many? 5. Okay, so 5 questions. Okay, so if you find the screen too small, you can zoom in the PDF file. Okay, so let's take a look at question 1. A cleaning cost of 80,000 for the lighting system in an office occurred at the end of year 10 by using a real discount rate of 5%. Okay, so this cleaning cost. So if we draw a timeline at the end of the 10 years, we will pay for this amount, 80,000, and we want to find the present value of this amount, and the discount rate is 5%. This is the real discount rate D. Okay, so 80,000 is AT, the amount of money that we need to pay at the time T year. And the discount rate is D. So very simple, just put these values into the equations. So in the suggested solutions, so very simple calculations. We put AT is 80,000 and D is 5%. So we have this value, the present value for $80,000 to be spent in the end of the 10th year with a real discount rate of 5%. Okay, so simple equation. And then question 2. The annual maintenance cost of the lighting system is estimated to be 10,000, and it is an annual cost. So it means it will happen every year. So it is a recurring cost. By using equation 1, calculate the present values of this future cost by the end of year 1 to year 10 using a real discount rate of 4%. Okay, so this equation is for one-time cost. One-time cost, sorry for the typo. Okay, so one-time cost. And we may use this equation to calculate 10 times for the present value at the end of year 1 and then year 2, year 3, all the way to year 10 for this $10,000. Okay, so if you draw the timeline, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 10 years. So every year we have to pay $10,000. Okay, all the way to the 10th year. So we may use the first equation, equation 1, to calculate the present value of the $10,000 spent in year 1 and then year 2, and then year 3, and then year 4. Okay, so we use this equation. And another method for calculating this recurring cost will be using the second equation. Okay, the second equation is for recurring costs. So instead of calculating the one-time cost 10 times and then add together, we may use one equation to calculate one recurring one present value for the 10 times of recurring costs. Okay, so just the same. If your calculation is correct, then you should come up with the same number. Okay, so using equation 1, the first year, so for the first year, t will equal to 1, and then for year 2, t equal to 2, and all the way to, this should be 10. So t will equal to 10. Okay, this one should be 10. Okay, so all these you add up together, then you have 81,109. So this is the first method. You have the answer. And the second method is to use equation 2. With one equation, you put 10,000, the real discount rate, and 10 years. So this is the total present value of paying $10,000 every year over 10 years. Okay, so just 2 methods for finding the recurring costs. Okay, question 3. The fresh water pump in a building is getting old. The facility manager would like to replace it by the end of year 5. There are 2 options available. Option A costs $50,000 and it will increase at a rate of 2% higher than the general price inflation. So this 2% will be E. Okay, E equal to 2%. So for option A, 50,000 with a escalation rate of E higher than the general inflation. And option B, 65,000, it will increase at a rate of only 1%, but 1% lower. So this E will equal to negative 1%, and for option A, E will equal to positive 2%. Calculate the present values for both options, and the real discount rate D is 5%. Okay, so 50,000, this is AT for option A, and 65,000, this is also AT for option B. And we have D, the real discount rate, and E are the rate of escalation. So if the rate of escalation is higher than the general inflation, then it is a positive value. If the rate is lower than the general price inflation, then this is a negative value. So once again, we put them into the equation. So AT, positive value, rate of escalation. And this is the real discount rate. And this amount of money will pay at year 5. Year 5. So this is the present value. And for option B, this is the amount of money to be paid in the year 5. The rate of escalation, 1% lower than the general inflation. And D is the real discount rate. So this is the present value. Okay? So actually the calculations is not, okay, or in the tutorial or for this subject, okay, for this subject, it is only an introduction to the life cycle cost analysis. So the calculations will not be too difficult, okay? So, and all these equations will be given. So you don't need to memorize the equations. You just need to know how to apply. Okay, what is the meaning of discount rate? This is the rate which reflect the earning power and also the general inflation of a company or a person. Okay, and how to find the present value, how to calculate the life cycle cost. So this is what you need to know. Okay. And question 4, the maintenance cost of a building services system involves an annual labor cost for 200,000. It is expected that labor costs would escalate at a rate 1% higher than the general inflation. So E will be 1%, okay, positive value, higher than the general inflation. Calculate the present value of labor costs over 30 years. So T is 30, and it is a annual labor cost. So once again, it is a recurring cost. Okay, it happened every year and for 30 years. The real discount rate is 3%. So this is D. Okay, so identify all the numbers and the equations are given. So 200,000 is AO. D, 3%, the real discount rate. And the escalation rate, 1%. And over 30 years. So N is 30. Okay, so question 4, 200,000, and then D, 3%, E, positive, 1%, and the number of years, 30. So we have this, the present value for the labor cost to be paid every year over 30 years. Okay, so the last question, question 5. A client is considering replacing their boiler. System A is an oil boiler system, whereas System B is a gas boiler system. Evaluate the life cycle cost present value of both alternatives over the life of the system, considering the following criteria. Which system has a lower life cycle cost? So the study period is 20 years. The real discount rate, D, is 5%, and the rate of escalation is positive 3%. So it means the price escalation or the rate of increase of the price will be 3% higher than the general inflation. Okay, for System A, the acquisition cost, so like the installation cost, the initial cost is £4,450, and for System B, £5,000. Annual maintenance cost, £175 for System A and B, and it is annual, so it is a recurring cost. Component replacement cost every 10 years, and the study period is 20 years. So it means the time will happen at T equal to 10 and also T equal to 20. Okay, this component replacement cost will happen at the end of the 10th year and the end of the 20th year. The annual cost, annual energy cost. So once again, this is a recurring cost, £500 and £460. Residue value, £500, £1,000. And these are residue values, so it will be a negative. Okay, we can earn money from selling the system at the end of its life. Okay, so we have D, E, and the number of study period. So this is N. Okay, and in the question, the equations are not given, but in the exam, in the test, the equations, you will be given the equations, so don't worry. Okay, so here are the calculations. So the acquisition cost, this will be paid in day 1, so no calculations required. And for the annual maintenance cost, it is a recurring cost, happen every year, so we should use this equation. Okay, so AO will be 100. Okay, and then E is how much? 1%. E is 3%. D is 5%. Okay, so E 3%, 3%, 5%, 3%, 5%, and then N is 20. Okay, for question 5, the study period is 20 years. So for calculating this 1,644, we put 100 into AO, and E is 3%, and D is 5%, and the number of years is 20 years. Then you should get this number. Okay, component replacement. And there are 2 values. One is for the 10th year, and the other one is for the 20th year. Okay, annual energy cost. So once again, we will use this equation. Okay, we use this equation. So this time AO is 500, and we have the same E, D, and N. The residue value, $500 today, it will be $340. So $500 in after 20 years will be the same as $340 today. Okay, so for the one-time cost, the equation will be this one. Okay, this is the one-time cost. We use this equation. And for recurring cost, we use this equation. All right. So after calculating all the present value, then we add up these costs. And remember, for the residue values, it is a negative. Okay, residue value negative. So we add them up, and we find that the system B is a little bit cheaper compared to system A. Okay. So the tutorial questions are actually very simple. Okay, so question 1 to question 4 are all basic calculations so that we can directly apply the equations that we have learned in the PowerPoints. And for question B, so we apply the equations for 2 system alternatives and then find out which one is more cost effective. All right. So I think I will stop here. Maybe you need some time to read the PowerPoint and then to digest the equations. So if we have the face-to-face teaching, I will just leave all these tutorials for you to do, and then after some time we can explain the solutions. So I really need you to do the calculations yourself. Okay, so you can repeat my calculations to check. Okay, try to check if I do the calculations correctly. Maybe there are some calculations error, maybe some mistakes. Then if so, then please tell me next week in the lecture. Okay, so please do the calculations yourself, and just directly apply the numbers, put the numbers into the equations, then you can get the answer. Okay, so not difficult at all. Okay, so I will stop here.